So these were where we started on the back of the envelope. It was a new build, it was 14 million, capital equipment 2.1, and refurbished the Purdy. We managed to fund about 5 million from the Wellcome Trust, and we targeted our own thing of excellent in BREEAM. So we set a target that we would build this BREEAM excellent at 75 points, right before this was just at stage C. So at that point at stage C, the academics sat and we agreed on key specifications before we moved to stage D. Okay, so stage C to me looks really just like the shell of the building. But stage D is much more detailed. So how we managed this was that I did the academic briefing. So I got all my colleagues in and we split ourselves by areas and we agreed what a bench would need to have, how many rooms we would have, what special or additional facilities would we have, like hot room, radioactive room is the one that we need. We needed category 3 containment. We discussed what those things should be ourselves without having the design team present, because it has been my experience of the design team individually briefed by academics. They always tell academics, of course it's possible, right? And so Professor X quite likes a dark room in this part because he thinks it'll look better. And then the knock-on effect of that dark room is a change somewhere else, and this is where the costs just go up. So we agreed amongst ourselves what it would be, and then a single person, in this case myself, went to the design team with Mark Simpson from the Estates Department and John Smith, who was our buildings manager, and the three of us briefed the design team once. And so we asked for some money back rather than because we didn't have all these meetings. Right? We said this should be cheaper. You don't have to go to all these people. We did all the internal stuff ourselves. They came back with a design. We took it back to academics as colleagues. We made our changes, things we wanted done, but the forcing academics in public to justify things meant that people didn't want to gild the lily. It's very easy when you're in a room all secret with the design team to say, oh yeah, I'd quite like a bigger office, or could you put me some windows in here? But in front of people where everybody knows the project has to be completed on time, on schedule, and budget, for people to stand up and ask for fancy things, much more difficult. Right? But it also meant that people were, because it was done in an open forum, you got good ideas, things that meant that we haven't had to go back and redo things. Because somebody say, oh, wait a minute, we'll need this. And everybody, oh yeah, that's right. And so that is one of the big, I think, advantages of it being done properly. John Smith and Mark Simpson came to the academic meetings and sat at the back, and if they needed technical help, they gave it. And I think that worked incredibly well. And I think the only time value engineering is useful is at this stage. Right? My experience of value engineering, because I was partly involved in the BMS building, is the value engineering at the end is just a disaster. Right? It's all about saving money. It's nothing about value. It's just what can we do to save money and still get the completion certificate from the local authority. There's no sense that it's of value. It's too late. The big decision's already made. This is the only stage where you can value engineer in a meaningful way. And so we all were involved in that at that stage. So we set our targets. This is McAlpine. So we told them right at the start, we want this BREEAM excellent. And I have to say, we were lucky, I should say, who the people were. So we had BMJ as architects, and Yvonne Roddy, or Yvonne Wood, I think now, is a superb architect. So she's very smart. She was fully on board with the notion of it being a green building, aiming for this BREEAM excellent. She has a nice line and understands how labs should be laid out, and we were very impressed with Sir Robert McAlpine. I'm not here, don't work for them. They were quite excited to deliver the first BREEAM excellent lab. That was something that they, as a company, wanted to do. And we found them very professional. They took some innovative steps in how they managed their site. So if you went into their site, they had a cafeteria on site that we provided, the university catering provided, so that meant the men weren't driving off site to get their lunch. And so that reduces the amount of CO2. They were recycling all the materials, and they had all these different things, and they gave this guy a special role. So he had a special coloured jacket, and he went around, and if he could identify a green saving, he got some sort of bonus, and this guy was great. You know, he loved going around and looking at stuff. So we designed, our architects of BMJ, the services are really important in the science building. RSP were the service engineers, Sir Robert McAlpine the builders, and we contract out the detailed project management to Turner Townsend. And I have to say, I found all of them very good. But one of the things that always helped was that because we had such a tight budget, the university by this stage had no more money than we were allocated, that it was very helpful to say, there is no project, that if you guys can't get this down, if you can't get it delivered for this cost, we won't be building the building, we will pull the plug. We put automatic sash closers on the fume hoods. The reason being we did not know in advance whether they would work. So fume hoods, you rely on the worker to pull them down. And it is the case that workers never pull them down. So they're always left open. And they're left open, then it's a high flow and you're basically just pouring money out the building. However, there is a safety element of these things that you have to allow the workers to have control. So we looked at a couple of control systems, and what we did was after the building was completed, we fitted 2 different ones in different labs and looked to see, did they work safely and did they save money? So we monitored, because the new building has all this monitoring, you can see what it does to the power consumption. And so sash closing works, but it took a bit of tweaking to make sure it worked in a way that was convenient for the workers, because always they have a bypass. Because in the end, they will always have to be in control of that because it's a safety equipment. If you put a sash closer they don't like, the first thing they do is they just disconnect it. Right. So it took a bit of tweaking because we had no experience with them. Now we have experience, it's been rolled out across the university. All fume hoods will be fitted with automatic sash closers. What that means is if they step away from it, the sash comes down, it puts it onto low power mode, we don't lose the heat. All the labs have water recirculating systems, so we minimize the amount of water we use. Because in the old days when I turned up, we used to just connect everything to the hose, pour it down the sink. We don't do that. We generate our own nitrogen, which is really important. It saves deliveries, so we use a lot of nitrogen gas. And so previously we had all these cylinders that we had to tank in and out, we had to store. We built our own nitrogen generating system that feeds the entire Purdy complex now. So we've dramatically reduced the number of deliveries that we have. One of the things that's very important for my own research is a type of making things very cold, and we use helium. Now helium is scheduled to run out in about 15 years. It always breaks my heart when I see kids with balloons of helium, because that stuff's incredibly valuable for science, because only helium can get you to really, really cold temperatures. And yet we're just venting it, and it's mined if you don't know how it's got. Can't get helium any other way, dig it out of the ground. And as we've decreased the amount of uranium that we're digging out the ground, we're decreasing the amount of helium. The United States has a mass stock of helium that Congress authorized to sell off. That's why balloons became popular 10, 15 years ago, because they sold it off really cheap. But now we are capped in deliveries. Anyone at a university will know that BOC only deliver a certain quantity. You can't buy any more. All universities are rationed for helium. And a lot of our equipment depends on it. So one of the things that we did in the building was put in a helium recovery system. So we now catch helium in this big bag. It's compressed down, and we have inside the physics department a condenser. So it takes the gas and then liquefies it. Okay? And that's going to be really, really important, because some universities are already turning off NMR machines because they can't get the helium. BOC won't deliver. So that's an environmentally driven saving. Although it saves a bit of money, it means that the science is sustainable. Because without this, we wouldn't be able to do a lot of our experiments. We don't have enough helium delivered. We have the only BREEAM outstanding. So I told you we were going for excellent, but being academics, there's no competition. We don't want to win. So we got an outstanding in BREEAM, which as far as I know is the only lab ever to get an outstanding in a BREEAM. It is because of the category 3, and this will relate to your animals, it's secured by design award from the police service. We got a carbon trust, highly commended for the building's use of carbon, and its energy performance is A, which is the only time that's ever been done inside the university. And the good news is, from a university point of view, that when we told you we designed it down, we actually underspent the project. We handed 100,000 back to the university at the end. And that is definitely the first time ever. Thank you very much.